Hello, everybody. Hello, everyone, and welcome back again to my channel. This is your yours truly, Juanito A. Mandia. I'm a registered nurse and a registered physical therapist. In today's video, we're going to talk about a brief review of anatomy and physiology of your blood or the hematology. Without further ado, let's start. Okay, so for hematology, of course, primarily your blood. So what does the blood do to our body? How it works? So what is their functions and how it will be is very important in our body. Okay, so primarily your blood is responsible for transporting oxygen through your erythrocytes or your hemoglobin. So oxygen is very important for our body, especially the target organs such as your brain, your kidney, your liver, your heart. Okay, and it also eliminates the product of impurities in your metabolism, like your carbon dioxide. Okay, it also carries nutrients such as your vitamins, minerals needed by our body, and as well as your hormones. Okay, aside from that, your blood transports gases or exchange of gases in the form of your oxygen and carbon dioxide. It's also, as I've told you, it carries waste products of metabolism that is not needed by the body. Okay, and also regulates the acidity of our blood itself, and it also regulates the water content of the cells through your plasma, and also it regulates the body temperature. So remember, when there is a blood loss, then it will change the body temperature. Okay, and protection through blood loss by your platelets, so through clotting, check on that, and protection by means of your white blood cells. So your WBC is responsible for fighting for inflammation and infection. They phagocytes or eat those viruses or bacteria that is needed to be eliminated on our body system. So those are primarily the functions of your blood. So how important it is, okay? Next, blood components. We have major components of your blood, including your red blood cell, check on that, your plasma, okay, your plasma, platelets, red blood cells, your WBC or the white blood cells. Okay, now let's talk about first the red blood cell carry and transport oxygen in the form of your hemoglobin. Red blood cell, don't forget about that. Okay, then the plasma, it carries water, salts, and enzymes and hormones or proteins as well. So we're gonna talk about that later, one by one. The WBC is for phagocytes or fighting for infection. Check on that. And the platelets is for clotting, so to prevent blood loss. Okay, so let's talk about first with your blood forming organs of our body includes the following. So we had the thymus gland, which is located here. So the liver itself, okay, and then the spleen is also bone marrow, lymph organs, and lymph nodes. Check on that. So remember, these blood forming organs, when they are destroyed or have injury, mostly the bleeding cannot be stopped, or sometimes it's like the blood is overflowing. So that's why you have to be careful on having injury on these parts of our body, because they are the blood forming organs. Okay, now blood is carried through veins, arteries. Okay, arteries will carry, as in A, away from the heart, which means they carry oxygenated blood, while the veins will carry deoxygenated blood because it towards the heart, so it carries deoxygenated blood like the impurities of metap to be oxygenated, except for pulmonary veins because it will carry oxygenated blood. So later on cardiovascular, if you're able to browse on that, the pulmonary veins will carry oxygenated blood. Okay, so remember that. Okay, next, let's start first with your red blood cell, or also known as your erythrocytes. Primarily, the function of red blood cells is to carry oxygen through your hemoglobin. But a little bit of background to that red blood cell is a biconcave shaped disc. So that's like a biconcave, it's like that. So anything that is elongated or not that shape is a problem with the red blood cell, like a sickle cell anemia. So if they are elongated, the sickling, so it means the red blood cell is not functioning well. Okay, check on that, remember that. The normal value for red blood cell is 4.6 to 6.1 million per cubic millimeter. So then the function is, it has called the hemoglobin, which carries and transport oxygen to our body. I mentioned that to you earlier. Now it colors red because of the hemoglobin. Okay, so that is color red. Now the portion of the blood, the portion of the blood cell into the red blood cell is called hematocrit. So it means the more blood cell it is, the more red blood cell. So it differs from value for male and female. So for male it's 36 to 42%, while for female it's much higher a little bit, 42 to 48%. Okay, now the lifespan of your red blood cell is 100 to 120 days. So they're freely living in our body and like going in and back and forth. So it's circulating on our body. But at the end of 120 days, they will die, and then new ones will be formed by your forming organs, such as your bone marrow primarily. So what would happen to your red blood cell then? Then they're gonna be eaten by macrophages and stored in the spleen. So it means those, this is the graveyard, or what we call the sweet home of your red blood cell is your spleen. So there they can be utilized again by the spleen and released again into the blood to be used up again by our body. Okay, so that's some portion. Now, other function of red blood cell is for immune response as well, aside from your WBC. They release free radicals to break down pathogens wall. So when the wall of the pathogens is break down, so the WBC can easily enter and fight and eat those viruses. So that's how it works with the. That's why it also work on like the antibiotics. So if the bacteria, the wall is destroyed, so they can easily treat or destroy the bacteria. So that's how it works with antibiotics too. Remember that. So that's for your red blood cell. Next, your WBC, or the white blood cell, also known as the leukocytes. This is very important as well because our body needs to have the homeostasis or equilibrium. So WBC is responsible for fighting of your body to infection or inflammation. The normal value is 5,000 to 10,000. So anything that would increase, so increase of 10,000 is they are having inflammation because the WBC is producing more and more to fight back for the infection. However, if there is decrease or decreasing the number of your WBC, or called the leukocytosis, so therefore your risk for infections, you can acquire a lot of infection. Example are those who have the HIV diseases or they have the leukemia. So that's why we have to protect the client. Okay. Now, for the types of your WBC, it has two types: your granulocytes and the agranulocytes. Okay. Now, granulocytes is the most common type of WBCs. They are the one who are fighting, boxing with the viruses or bacteria or any pathogens inside our body. Now, other form is the agranulocytes, which are types, are example, are the monocytes and the lymphocytes. Okay, the monocytes are those are macrophages or phagocytic function, like a Pac-Man that eats your pathogens, while the lymphocytes is a form of immunity. So these are your antigen and antibodies. So your antibodies, I mean, that is responsible for the immunity. Example of these are your T cells that provide protection to our body. So if these T cells, they are responsible for fighting with or giving us immunity to a certain diseases. Okay, so that's for your WBC. Now, WBC is produced primarily on the bone marrow and hematopoietic cells of our body. So through bone marrow and hematopoietic cells. Okay, so that's why, remember, if a person is having a bone marrow diseases, that's one of the cancer that a lot of clients is not surviving. Okay, because they are risk for a lot of infections or inflammatory reactions in the body. Next, let's talk about the platelets. Now, remember, platelets is responsible for clotting, to decrease the bleeding or stop the bleeding. Okay, the normal is 150,000 to 450,000 microliter per blood. So anything that would decrease with that is a risk for bleeding. Okay, so but sometimes person like they would have that 10,000, their internal organs are bleeding, or like 3,000. Oh my God, they were bleeding everywhere on the nose, ears, eyes, mouth, because bleeding cannot be controlled. Okay, now this is for clotting and prevention of blood loss. Now, if this decrease, it will lead for bleeding. Okay, and leading to shock and death eventually. Now, it's derived also from bone marrow. How important is your bone marrow, isn't it? That it's on a musculoskeletal, so we need to protect that too. How to be strong? You have to do exercises like walking, running, standing, jumping. So those are examples to exercise your bone. Okay, now this is an example of your platelets on the picture, together with the other components of the blood. So when there's injury on the blood vessel or to your muscles or internal organs, platelets, they will be released immediately on the blood and goes to that certain target of injury, and they form a cluster of platelets to clamp the blood and clamp the blood and therefore decrease the bleeding. Okay, next is plasma. So plasma constitutes the largest portion of the blood components, which is 51%. So remember that they are mostly the water. 50 to 60% of the blood plasma are proteins. How important the protein is, because they are responsible for healing process. So the more protein you recruit, and therefore you're going to heal a certain injury. Okay, remember that protein is important, and especially our body is made up of protein, including your tissues, your skin, your nails, the hair, everything on our skin are protein. Okay, now how to assess for plasma? The normal albumin is 3.5 to 5.5 grams per deciliter. So that's why when there are a lot of water, edema will occur. So remember that. Okay, so that's why too much water will cause you to increase weight, leading to water reabsorption and leading to edema on our body. The generalized edema called anasarca. Okay, plasma is used primarily to given for those who had the injury like trauma, burns, shock, because they could increase the blood volume easily. Increase the blood volume and as well as increase the blood to the area. So you will not be dehydrated and you will not to have like hypovolemic shock. Okay. Now it helps also boost the blood volume and blood loss. That's what I'm talking about. Now the functions of your plasma, aside from what I'm talking, are it carries water and salts and enzymes. Check on that. Take nutrients from the hormones and proteins to the parts of the body that needs it most. Okay. So hormones, especially the hormones, they are important, like your diuretic hormone, like your growth hormone, sex hormones. There are a lot of that, so they are very important. Okay. Next, the ABO blood compatibility. Now, these are the blood type. Okay, remember this. Sometimes they have negative, positive, negative, but in NCLEX, they usually ask questions about general questions like what do we need type of blood and blood interactions, what are the signs and symptoms of blood negative interactions or positive interactions with the blood incompatibility. Okay, blood types are AB, AB, A, B, and O. Now let's talk about the AB type. They have antigens A and B, and they don't have the antibodies. That's why they can donate blood to AB, and also they can receive blood because they don't have antibodies, so no reaction, so they can receive AB, A, B, and O. So remember that they are universal recipient. Okay, the type is the universal recipient. Okay, if you are type A, you have antigens, but you have antibodies B. So the type blood B cannot receive with type A, so they would have a interaction with that. Okay, so can give blood with type A and AB because it has antigen A on the AB, so they can receive type A and type O, but not type B. Remember that, okay? Remember, okay? Now, type B, they have antigen B, but they have antibodies A. So it means it cannot receive type A, okay? It would have a fight or boxing on the blood interactions, so, okay? Now, can give blood, can donate blood to type B because it has antigens B. It can also give blood to A and B because it has the antigen B. Okay, but not with type A because it has antibodies A. Remember that. And it can receive blood B, and it can receive blood O. Okay, that's okay to receive blood. Okay, with the B. Now, if you are type O, they don't have antigens, but they have antibodies with A and B. Okay, so it means no type A and no type B. Choosy. Type O is choosy. Okay, so it means no A and B, they will have interaction. Okay, can give blood or donate. If you are type O, you can donate to A and B, A, B, and O because it has no antigen. Okay, so you can donate, but type O can only receive from type O because it has antibodies A and B. Okay, remember that. So it means that type O is a universal donor because it has no antigen, so it can donate type AB, A, B, and O. So it is a universal donor, but it can receive type O only. Okay, remember that. Okay, so who is a universal recipient? Your type AB. Who is your universal donor? Your type O. Okay, so just a little bit of that. And that'll be all for your hematology. I hope you learned from this video. Thank you so much for watching, and God bless you.